Hi everyone, welcome back. Sorry for the interruption. We had a technical problem. My machine crashed, so I had to restart my machine and set up the Kubernetes Chorus cluster again. So sorry for the interruption. We will continue from where I dropped. So I was talking about how we can access the service. Uh, so we can access the service using this member private IP and the allocated service port. So, so there is two way we can get this allocated service host port and the member private IP. Either we can log into the CoreOS master and we can get it from there, or else we can get it from our CLI tools. So first, see how we can get it from the CLI tool. So you just list members. Uh, my PSP. So here you can see so our main replicas is two, so we have uh, two members here. Here we have the member private IP, and here we have the service port. The service port is 1500, and the private IP is 172.1780.17800. So let's access the service that we have deployed. So this is the address. uh, Let me check again the IP 100. So 100 and the port is 4500. So now, so this is my application now. Uh, I have constructed this application in my GitHub, and the Docker container on the PHP subscription JSON we gave the subscription URL, and now it is cloned there, and you can access using the member private IP and the service port. So if, for example, if you change the service port to something else, you can't access. So you need the service port here. And then another important thing is here we have this one Horos master and two minion, and the Horos master IP is 100. I mean, it is ending with 100, and minion is 101, and minion 2 is 102. So you can access using any IP. Because the Kubernetes is doing load balancing there, so you can access using any IP, any three IP. I mean, any IP of the host in that cluster. Uh, so if, for example, if this host uh, goes down, for example, minion one goes down, you can still access the service using the IP of this one. So that's an advantage we are having. So now we will put some changes to my GitHub repo and see whether the changes are coming here. So this is my that application. So I'm going to change the topic, change the heading. So we'll change the heading to M3 developer preview. We'll commit this. Now it's committed. So now what's happening is, I mean, we have pushed our changes here. It will automatically detect, and the changes come here within a 1 second or 2 seconds. We got the changes here, and for every host it is changed now. Okay. Now if we see our log, this is our status log. Here you can see our cluster monitor is executing our mean check rule, obsolete check rule, and the scale check rule periodically uh, in every 1.5 minutes. So here you can see non-terminated replicas is 2 and the min replicas is 2, and obsolete replicas is 0. So obsolete check skipped, and scale check min replicas is 2, max is 20, and non-terminated 2, active 2. So we don't need to scale up here. So now I'm going to show you how we can auto scale. Next thing is I'm going to show you how we can test the auto scaling with this developer preview, M2 developer preview. So in this release, auto scaling works based on the load average. So if we can stress the instance, the load average will automatically increase and will end up with creating more containers. So within 2 or 3 minutes, we will be creating and activating more containers. So let's do that. So in order for that, you need to know where the containers are there. So you just type the command in the master kubernetes kubectl list pods. List the pods. Now, as I told earlier, one pods have one container now. So here we have the cost IP. Okay, so 101 means it is in the minion one, and 100 means it is in the master. So master have one Docker container. Docker PS, you can see master have one Docker container, and minion has one Docker container. So Docker PS means Docker process. It will list the Docker containers. So let's go to the minion one, and let's try to log into this instance. So this is the Docker container now. So in order to SSH, we need the IP. So Docker inspect and the container IP, and we are grabbing for the IP. So we are getting the IP now. So let's log in. Yes, the password is G. So you are now inside the Docker container. So let's check for whether the okay, the agent is running now. So we will stress the instance now. Uh, Before that, if I show you our here, you can see our application is downloaded here. So let's stress the instance. So you can use this stress tool. If you want, you can install using apt-get install. Our Docker image is already had this. We have already installed it, so you don't need to install. So stress uh, number of process. Let's give 5. So now I'm creating 5 different threads parallelly, and I'm stressing the instance. So let's see the log whether the predicted values are increasing for the load average, because we are stressing the instance. Now I'm stressing the CPU, because in my argument I gave stress minus C. So if you want to stress the memory, you can give stress minus M. The current load average is, you can see here, predicted value is 3. My upper limit is 180. My lower limit is 20. But in Docker case, we are not going to use the lower limit anymore. We are only depending on the upper limit. If the predicted values goes beyond upper limit, we are scaling up. It is come below the upper limit, we are scaling down. Okay, so now here you can see predicted values now 90, from 3 to 90 in 1 second. We created 5 different process in one container. So still my upper limit is 180, so should go up to that, then only we will scale up. So here you can see the decision. Even if all the predicted values are below the upper limit, we are not scaling down, because if if the predicted values are below the upper limit, we should ideally scale down, but we are not scaling down because it's less than or equal to the min replica still. So it is preserving the min check also, the scale check. still stressing the instance. I hope in the next minute it will go beyond 180. You all can hear me, right?
Yes, sir.
Okay, so predicted load average becomes now 196, but my upper limit is 180. So the predicted values is now 3. That means the predicted replicas is 3. And again, we are validating how many replicas we can expand. Actually, I mean, prediction can say like we can go up to 50, but there's a max limit. So this message is for that. We are like validating the number of replicas to expand. So it is now 3. So we are asking Kubernetes replication controller to update the values to 3 now. It was earlier 2. And you can see members created. So if you come to Kubernetes master, and if you list the, you can see now there are 3 pods, 1, 2, 3, and this 101 have 2 Docker containers now. So member started event came. So I will now stop the stressing now because it is enough, and I will exit from the container, and I will do a Docker ps. Now you can see there are 2 instances now. One Docker containers have 2 entries here. It's kind of linked to this one, so we have 4. So it means we have two Docker containers here now. And now the predicted values is 233, and the upper limit is 180. So still we are predicting we need three replicas. So we are not updating the control because already we have 3 non-terminated member. Now member is started and member is activated. So if you go to the CL and issue the command, now you can see we have 3 members. Okay, so it auto scaled. I hope in the next minute the load average will come below 180. In that situation I can show you it is all automatically scaled down, and within 1 second the member will be killed and wiped out from the cluster. Ideally we should reduce this cluster monitor interval for this Docker, because we are using the same time as VM now. It is 1.5 minutes, but we should monitor very often, like 1 minute or even below that. So now you can see predicted value becomes 177. So that is below upper limit. So what we are doing is we are shrinking the cluster to the main replicas, right? Because if the predicted value is below upper limit means we should ideally keep them in replica. So we are shrinking the cluster to the 2. So here you can see member terminated. Member terminated. So if we go to the member is not there. It is killed and wiped out from the uh, cluster. Here we have only one container now. So as you can see, so this is auto scaling. So auto scaling works very fast with Docker containers based on load average. Now we in M3 we are going to work on this LB also, like request in flight. And now see how we can manual scale the container. So there can be a situation like actually there are no loads, but you still want to increase the count, increase the min replicas for some reason. So how we are doing manual scaling is we are altering the min count because we have a min check. So if we alter the min count, I mean if we increase the min count, that min check will be preserved, right? So it will preserve the min count. So how we are doing manual scaling is to alter the min count. So if you increase the min count, it will create more containers. So that's the manual scaling here. So this is the JSON. For the manual scaling, you can specify property like Kubernetes replicas min count is now 10. So it will create 10 more instances. So let's go to our CLI tool and see how we can update the how we can manually scale. So update subscription, my PHP, and the manual scaling JSON. So update subscription, uh, and the aliases, that is my PHP, and the path manual scaling. Before that, I will show the. So here you can see in the manual scaling JSON now I have five main replicas, but currently is 2. So it will scale up to 5 now. So here you can see that now the min count is 5. So this is the min rule check, right? So min count is 5, and we are printing the decision like min rule not satisfied. So scaling up to min replicas, that is 5. So we are asking Kubernetes replication control to increase. So in the next second, or in the next millisecond, you are seeing non-terminated 5. So that means it created 3 more within a second. Now all 3 is created now. Here member created 1, 2, 3. So if we go to the master and type Kubernetes list pods, now you can see now 5. So master node have two Docker containers, and the minion have 2, and now the minion 2 have uh, 1 Docker container. Okay, so everything is running now. So we will get the member activity event eventually. Now we are getting the member started event. We will get the member activity event eventually. So like we scaled up, like we manually scaled up, it is possible to manually scale down. So what you have to do is you have to give the min replicas. I mean, you have to reduce the min replicas and call the update subscription method again. So I'm waiting for all the members to be active so that I can show you how fast it is, how fast uh, the 3 members are activated. Okay, so member started. We got the member started event for all 3 members now. Here, publishing member activated event. In the meantime, if you have any questions, you can ask. There are some more commands that you can try out in this master. Like if you want to list out the uh, available replication controller, you will type so you can see, okay, this is the ID of my replication controller, that is equal to the cluster ID, and this is the image name, and we have an alias here, and the replicas is 5 now. So it is printing for replicas is 5. And if you want to list the services, Kubernetes list and also you can see the I already told. Here also we can get the port, service port is now 4500. Okay, so all the members are now activated. You can see. So in the next scale decision, we can see how many members are activated actually. Then I will update the manual scaling JSON to reduce the count. Then I can show you how it scaled down, how fast it scaled down.
Raj,
Yes.
just a small question. Why don't you take the lower limit into the consideration when you are scaling down? You're only
Yeah.
taking upper
In
limit, right?
Docker containers, what we are going to do is so this creating and activating Docker containers is very fast. So we are going to predict how many instances we need, and we are going to increase up to that limit. But in VM case, if the predicted stats are going beyond the upper limit, what we are doing is we are increasing one by one, right? We are increasing one, and again, if it is not satisfied, we are increasing one. But here, what we are going to do is, if we exceed the upper limit, we will calculate how many replicas we need. So that means, so if the, let's say if the upper limit is 100 and your min replicas is 2 and your predicted stats is now 200, so that means we will scale up to 4, because your min replicas is 2 and your upper limit is 100. That means you are assuming that 2 min replicas can handle up to 100 100%, I mean 100 percentage of load average of the cluster, right? So if it goes to 200, we will scale up to 4. Then if it comes to 150, we will scale down to 3. Then it will come down to 100, we will scale down to 2. So we don't need this I mean, we don't need this lower limit concept here.
Okay, got it. Thanks, Raj.
So here you can see active replicas is now 5. So all 5 are now activated. So now I am going to update my JSON manual scaling to say 3. We will kill 2 and we'll update subscription. Maybe it is updated. Now we'll see how fast it is killed. Yeah, it is a waste of time. As you can see, the loco can actually kill the container very fast, but the monitor interval didn't come yet. So the monitor interval is 1.5 minutes. So we should ideally reduce this, because it will execute after 1.5 minutes, but actually to kill the instance we need only 1 or 2 seconds. So but we are waiting that 1.5 minutes, so that is a waste. So we should reduce the monitor interval to something 67 or so. It is now configurable. You can, I mean, each cluster monitor can have different monitor interval. It can be configured via the autoscale XML. And now you can see we shrink the cluster to 3 because we manually updated. And now member terminated, both are terminated. We will see the members, and we have 3 members. 1, 2, 3. So we have manually scaled down. So manual scaling is done, auto scaling is done, and now the last thing is unsubscribe from Docker cartridge. So if we unsubscribe from a Docker cartridge, it will be like the whole cluster will be wiped out in within 1 or 2 seconds. So let's do that. Unsubscribe cartridge. PHP. Okay, so subscription checking. Okay, so there is some, because it is still hanging there, so the request is not gone or something like that. Uh, yeah, we have success. Now only it reached. Like, so here the cluster removed and publishing cluster removed event, and we have killed all the like we have removed the cluster monitor and so on. So as soon as this request goes there, I mean within 1 second it it wiped out. Here we have no cartridge, but it's returning an internal server. Let's look at the master services. It's not there. It's wiped out. Uh, so that's it for the for this demonstration. So if you want to explore more, you can find this 401 into developer preview user guide. We have included in the wiki, Apache wiki, Apache Stratos wiki, and you can find more information about Apache on Apache website. So if you have any questions, you can ask now.
Hi, Raj. Can you hear me?
Yeah.
Uh, so so according to current implementation, we haven't tried the Docker scenario with LBs, okay, right?
Sorry, I didn't get you. Like,
Load balancers.
yeah, yeah, load balance. It's we are still researching on the how to do that, but in
Mhm.
the M3 release it is coming.
Okay, so basically it should work with the Stratos load balancer, right?
Yeah.
All right. And another point I had in mind was the CLI command for listing members in the Kubernetes group, basically.
List groups. Yes. We need more information here.
Sorry, not this one.
Hmm.
Members. When you list the members of this group one.
Okay. See the command again.
It should be list Kubernetes host. Raj.
You mean the Kubernetes host?
Uh, it should be yes.
We should pass the ID.
Yeah. That one. Yeah, you passed the group ID there. Mm, so now this is in the table, but earlier we saw a command where we had a list of properties in members. Not
Mhm.
sure whether it's same command.
You so you are asking about listing members or
Yeah, listing members. So yeah,
listing
sorry.
members of the
Again, this
cluster.
of the cluster. Yeah, basically that one.
List members allies my PSP cartridge type is PHP
Mhm.
because the cluster is not there.
Yeah. So basically, what I want to say is we can make a table from that as well, right? So is it
Yeah.
yeah, is it like a temporary one until we get the load balancer in place? Because we
Yeah, it's just an initial version. We can improve it.
yeah, I mean whether I just want to check whether it's a permanent command or we are having this until the load balancer is come in? If it
No, no,
is
we are having this command anyway because it is
yeah.
already there, right?
Mm,
Like
Yeah,
listing members of a cluster is already there in the CLA tool.
okay. Okay,
yeah,
so then we can make a point to make it a table.
yeah. Lahiru,
Yeah,
the concerns with the load balancer is are that so currently load balancer consider load balancer means list of members, right?
yeah, yeah.
So here, what happens is when we create containers,
Yeah.
we front a set of containers with a proxy service.
Okay.
So that is the design of Kubernetes.
Yeah, yeah, yeah.
So
That's why
then,
we get like identified by ports, right?
yeah. So then we
So
need to talk to containers via the proxy service. Then there should be a mechanism in the load balancer to point to the proxy services, not the members.
yeah,
Yeah. So basically, like the same way we do communicate to member, right?
Yeah, yeah.
Yeah. So for
So
example, you use the 4500 as the port and same host for same both members, right?
yeah,
yes.
Yeah. So basically, from load balancer point of view, it should be like host and port combination, which should be unique for member.
It's like this. Actually, still we can use load balancer with the current configuration because
Mhm.
Kubernetes also supports to access members directly with by bypassing the proxy service.
Okay, I see.
So, that is also possible, but according to Kubernetes design, it's better
Mhm.
to access the members via the proxy service.
Okay, now the problem is that normal clusters we are differentiating nodes from IP. Here we
Okay.
are differentiating the instance from port, right? If we are going through the proxy.
No, actually, that's because the initial version of Kubernetes didn't support to assign multiple IPs
Okay.
to different services on the same host.
Yeah. So
So the coming release of Kubernetes supports that. So within
okay,
the
cool.
same host, even we can assign the same port for multiple services.
Okay, now and then we will be able to do the same
Yeah.
like other VM
Yes.
scenario.
Yes.
Okay, cool. Thank you. Raj, one question for you. Another one.
yeah,
Uh, Here we are using the upper limit for scaling.
yeah,
Why don't we use the lower limit?
yeah. As I explained earlier, they also asked the question. So this is uh, not upper limit. Rather, it is a threshold.
Yeah.
What we are going to do in the Docker containers is, according to the current predicted stats, we are going to predict the number of containers we need, and we are going to scale up to that point. We are
Mm-hmm.
not going to scale one by one.
Mm-hmm.
So if we exceed the threshold, we will calculate how many we need, and we scale up.
Yeah.
And
So.
if we come below upper limits, if all the stats like
Mhm.
in-flight requests and memory consumption and this load average, if all three comes below upper limit, then we will
Mhm.
shrink the cluster to min replicas, because that is what user defined in the JSON. They are saying like, this is the min replicas and this is the upper limit. So they know, uh, I mean, two min replicas can handle 100% of this uh, load.
Yeah, I mean, as per current implementation, until we get that instance count into play, we are just scaling up and down, right?
Currently,
Currently, we are just increase one by one, right?
no, no, no. We increasing. We are predicting and we are increasing that much.
Yeah, yeah, I mean, we are adding nodes one by one, not like calculating, say, we have two instances, then we calculate it as a four and we
Yeah, yeah,
directly do.
yeah. That's how we are doing. If you are predict, so let's say min replicas is 2 and the predicted replicas is 10, we are scaling up to 10. We are not growing by one
Now
by one.
it's okay.
Yeah,
Now it's in place, right?
yeah, yeah.
Okay.
I can show you now. This is how it's working.
All right. No need of showing again.
Yeah,
So okay. I thought like we are using scale up and down. Then the threshold threshold concept is the best way.
Yeah,
Yeah, okay. So we will like depreciate upper limit and lower limit, and we'll have one threshold, right?
yeah.
Yeah, okay,
But
cool. Thank you.
but for the VM scenario, I don't think it will work because
Yeah.
creating containers, creating VMs and destroying will take some time.
Okay.
So we can't like predict the VM and uh, I mean we can't kill at once. So there should be for the containers also in the scaling down scenario we are not going to scale down quickly. We are going to implement CEP to calculate the this stats in a 10 minutes window. Then scaling down scenario we can use that because uh, I mean we
Yeah.
don't I mean we are not like to reduce the count quickly because
Yeah.
yeah,
So basically, we are scaling up on 1 minute window and scaling down on
10
10
minutes,
minute window.
yeah,
Yeah.
exactly,
Okay, I
yeah,
remember. So, but I think here in VM scenario also, uh,
yes,
so even the Docker takes few seconds to comes into live if the application is taking, say for example, we have some app server like Tomcat. Say it gets 3 minutes to get up and running.
okay,
So basically, we might have the Docker in 1 second, but the application will take that 3 minutes.
yeah. Normally we are installing the Tomcat in the Docker image itself, so it is the time to up. So it might be I don't know, it might be take 3 minutes or
Yeah.
less than that. So
Yeah, say we have such application. So in
yeah, yeah,
that kind of scenario, I don't think it is going to make a difference whether it's Docker or VM, because VM also anyway uh, maximum it will get like 2 minutes,
yeah.
and we are talking
But
about 5 minutes and 3 minutes then.
but if you see like killing containers and killing
Yeah.
uh, that that make a difference, right?
Okay, you mean the
Scaling
uh,
down.
scaling down.
Yeah.
Oh, okay, but scaling down. Uh, okay. So I mean, what's the difference?
No, when we, I mean, if let's say for example, if you answer scripting a service,
Yeah,
this Docker cluster will be
yeah,
wiped out within 1 second. But
yeah,
in VM scenario, you have a life cycle, right?
yeah.
So it will take at least 5 minutes or like to to to
Mhm.
shut down the whole cluster, right? And there are some other advantages also.
Mhm. Okay, I think we can discuss this in
Yeah,
devolution later. Yeah.
in a later.
Okay, cool. Thank you. That's all from me.
So if any questions? No. Okay, then I think we can summarize. Uh, yeah. So thank you all for joining this session. Uh, thank you very much.
Thank you, Raj. It was great.